Okay, in identity matrix, the major thing is we have to think about square matrices only. Okay, here we are going to think about the square matrices only under the topic identity matrix. So, uh, what is a square matrix? Number of columns equals to number of rows. Likewise, let's do something. Okay, here I'll indicate 3, 5, 0, -2. Okay, this is a square matrix 2 into 2. And then my next square matrix is 10, 5, 1, -4, 0, 0, 0, 5, -3. Okay, this is 3 into 3 matrix. Okay, we know about square matrix already. But in identity matrix, the common diagonal, okay, we have to think about the main diagonal. Main diagonal. So, okay, this one, the main diagonal should hold number 1. Okay, number 1 only. So, when we think about this is not an identity matrix. Okay, when we construct, I'm using this one for the explanation. Okay, when we consider 2 into 2 matrix, the main diagonal should be hold the number 1 only. Okay, this is our main diagonal. So main diagonal should hold number 1. Other remaining values should be 0. This is 2 into 2 identity matrix. What happened here? Main diagonal will hold a number 1 participants and remaining all the remaining values are equals to 0 in the star matrix. So this is a an identity matrix. Okay, this is an identity matrix. When we consider about the main diagonal, in this one, this is gonna be our main diagonal. Okay, don't think about this diagonal. Okay, we are talking about only the main diagonal. This one is our main diagonal. What it says, main diagonal should hold number 1 participant. So 1, 1, 1. Remaining all the remaining values should be 0. Okay, all the remaining values should be 0. So here 0, 0, here this side 0 and 0, here there are two zeros. This is our 3 into 3 identity matrix. Okay, 3 into 3 identity matrix. Why I use this? To identify the common diagonal, I use this orange color examples. Okay, these are not identity matrix. For identity matrix, this one is our 2 into 2 identity matrix. This one is our 3 into 3 identity matrix. This is a summary of identity matrix. Okay. Common diagonal should hold only 1 digits. Remaining quantities are 0. So this is our 2 into 2 matrix. In identity matrix, we are only considering about square matrices. Okay. Not other column matrix or row matrix. Non-symmetrical matrices, we are not using them. We only consider about the square matrices. Okay, this is our 0, 0, 0, 1, 0 and 0, 0, 1. Okay. This is our 3 into 3 identity matrix. The common diagonal is holding 1 digits, remaining are 0. Okay, what is the condition for identity matrix? Common diagonal will hold equals to 1. Okay, equals to 1. Remaining quantities are 0. Likewise, you can indicate that one easy words, common diagonal 1 and remaining 0. In symmetric matrix, the thing here also we are only considering about square matrices. That means 2 into 2 matrix and 3 into 3 matrix. Okay, square matrices only will be concluded in symmetric matrix. So, for an example, I'll take 2 and 2. The common diagonal will hold any values. Okay, common diagonal will hold any values. Here -1, here 2. Okay. Rather than the common diagonal, other remaining values should be in a symmetrical way. This is kind of a mirror. Okay, mirror image. When we think it as a mirror image, here if we have 3 here, this one also should hold 3. Okay, this one also should hold 3. There is no any problem with our common diagonal values. Okay, any values are possible. Okay, even 0 also possible. When we consider this one as a mirror one, both sides should be symmetrically aligned with the mirror image. If here 3, this one should be also 3. When we consider about 3 into 3 times of square matrix, yeah, I'll indicate my values 5, 3 and 0. Okay, this is our common diagonal. Okay, when we think the common diagonal as a mirror one, other side, okay, other remaining value should be symmetrically aligned. Okay, kind of a mirror image. So if here 1, this one is -4 and this one is 2. Okay, so this is 2, -4 and 1. Okay, you should think, oh, sorry, you should think this one as a mirror one. So 1, 2. Okay, when you bind, okay, when you bind your page, okay, you are writing these 9 values in a page. When you are binding that one through this common diagonal, okay, the remaining values should be aligned with each other. So when we bind this 1 and 1, -4 and -4, 2 and 2, this is the way we have to identify our symmetric matrix. Okay, but is the explanation for symmetric matrix? Common diagonal can hold any values. There is no any restriction. Mirror image of, okay, mirror image through common diagonal should be symmetrically aligned. Through common diagonal I'll indicate remaining here, okay, should be symmetrically aligned. Okay. This is the way you have to identify your symmetric matrices. Okay, symmetric matrices. What we did here, I'll repeat once more what we did here. First of all, we are going to only take square matrices in this case also, like as our identity matrix. The diagonal values, there is no any problem with our common diagonal values that can hold any values, any numbers. Okay, so then after when we think this one as a mirror one, okay, when we bind this page accordingly, so the remaining value should be symmetrically aligned. That is our condition for our symmetric matrix. Okay, here the diagonal, that's not a problem. When we think about the remaining values, 1 and 1, -4 and -4, 2 and 2. Okay, this is the way we have to identify our symmetric matrices.